recording line. I hope it is. Yes, sir. So last week, basically, we did methodology of econometrics. I'm sure you have done that with legal class. So you can go back and listen to the video. Today we are going to focus on types of data. We did this in class with legal, right? Yeah. That's class. Okay. We have 3 types of data basically. Time series data, cross-sectional data, and panel data. What's the difference? What's the difference? Yes, time. Time series data is data which studies one subject many years. Well, I'll just put years, but it might not be years. We might have monthly data, daily data. If it is in years, it is annual data, right? Cross-sectional data studies many subjects for 1 year. Of course, these subjects, we can also call them cross-sections. So you notice the difference. Time series data studies one subject for many years. Cross-sectional data studies many subjects for 1 year. Then, if I call this A, I call this B. Panel data is like A plus B. So it's like a combination of time series data and cross-sectional data is panel data. If I'm to give you an example of time series data, for instance, let's say we want to study the economic growth of Turkey from 1990 to 2020. Let's say Turkey. We want to study the economic growth, GDP. We know we proxy economic growth with GDP, right? So let's say we have GDP, we have years. So let's say we have 1990, 1991, 1993, 1993, 1994, 1995, just an example. So in 1990, we are going to have the GDP, let's say maybe 40, 1991, maybe 50, 1992, maybe 70. So every year we'll have the GDP. So if we are studying the GDP of Turkey from 1990 to 1995, this time series data. So we discover that we have just one subject, which is Turkey, one subject, and we are studying it for many years, time series data, right? And we must not have just one variable. We can have many variables. So we can have maybe income, we can have maybe trade openness, whatever. So we can have. So don't think that the subject are the variables. You know? The subject here is Turkey. Because I'm saying so because since I said one subject, you might be tempted to think that just one variable. No, the variable is different. Just Turkey, one subject, many years. But if we want to look at cross-sectional data, for cross-sectional data, we study many subjects for just 1 year. So for cross-sectional data, an example we can get is, I can say, let's say country, and let's say GDP, income, maybe trade. So let's say we have Turkey, Cyprus, Nigeria, Uganda. Then we have the figures, of course. So what do you notice? You notice that, so let's say we are studying, we are doing this study for 2020. You notice that here we have many subjects, many cross sections. This study was only for Turkey. Then this study is for Turkey, Cyprus, many different countries, right? And this study was from 1990 to 1995. And this study is only for 2020, 1 year. So we studied many cross sections for just 1 year. Forget about the variables. The variables has nothing to do. Many cross sections, 1 year. That's cross sectional data. One subject, many years, time series data. And then panel data is like a mix. So for panel data, we study many subjects for many years. So in this case, we are doing this study for just Turkey. If we have to do this study for, let's say, Turkey and Cyprus, it becomes panel data because we are studying many years and we are looking at more than one country, right? Okay, I will show you an example. By the way, if you watch the video of last class, I showed you how to download data from Data Bank and also from Yahoo Finance. Those who have not watched the video, you have to watch it. So I'm not going to show you how to download data. I already have data here which is being downloaded. So you discover that this is time series data. This, let me open. If you discover this data, I downloaded it directly from WebBank. When you download data from WebBank, it comes to Microsoft Excel. So you discover that it is data for Turkey. Then, of course, you know when you download your data, it comes in horizontal format. You need to transpose it to vertical format on Excel. I showed it last class. Those who have not watched, go back and watch it. So this is when you arrange the data, it's in this form. You have to arrange it in this form before you send it to eViews. So this is time series data. Why time series? Because you see, we have many years, and it's just one country, Turkey. Of course, we have the variables, GDP, CPI, population growth, unemployment, whatever. So that's time series data. And I also have here another data set I downloaded, cross-sectional data. Okay, this is cross-sectional data. Why cross-sectional data? Because this study is only for 2017. And we are looking at many countries. You see, Afghanistan, Algeria, and so on. Of course, we have GDP, CPI, we have two variables. Like I'm telling you, don't bother about the variables. To know if it's time series or cross-sectional, look at how many subjects and just 1 year cross-sectional data. Okay. Now, if you want to export this data from Excel to eViews, how do we do it? So I'm opening eViews. Please, those who don't have eViews, try to get it. If you solve a problem, share it with them.
Yeah, fine.
Okay. And by the way, after this class, I'll give you your first assignment, and you have to submit the assignment before next class. And I'm sure I'll talk to Niga Hoja. I'm sure maybe next week or next 2 weeks, you will also have the first quiz. So if you open your eViews software, like the file, this is the first page you will get. You come to create, I hope this thing is recording. You come to create new file. When you come to create new file, it's interesting here. Here you see unstructured, undated, dated, regular frequency, balance panel. If you are working with time series data, then you choose this one, dated, regular frequency, right? If you are working with, and if you choose this one, you also come here. If it is annual data, that is every year, you choose annual. If it is every month, you choose monthly. If it is twice a year, you choose semi-annual, and so on, so annual. So we are choosing dated regular frequency for time series data. If it is cross-sectional data, you choose unstructured, undated. If it is panel data, you choose balanced panel. Well, with panel data, we can either have balanced panel or unbalanced panel. So if it is a balanced panel, you choose balanced panel. If it is not a balanced panel, you choose unstructured, undated. I will not focus too much on panel data because we don't really do panel data in this course. There is another course FINA 514. It's an elective course. For those who want to do PhD here or anywhere, PhD in finance, I would advise you to take that elective course. I took the course last semester, and it is helping me this semester because this semester I'm doing time series econometrics PhD course. Those who want to do PhD, I would advise you to take FINA 514. So you will do more of panel data there. So now, let's go back to dated regular frequency. So we choose this option if we are working with time series data. Now, how do you upload the time series data from Excel to eViews? Okay, I'm going back to my Excel file. This is our time series data, right? The first thing you need to know the start year and the end year. You discover the first year is 1991 and the last year is 2019. You go back to eViews, you have to put in that information. The start date is 1991 and the last date is, was it 2019? 2019. Once you put in the dates, you click OK. It opens. The first thing you have to do is to generate the command, right? So you look at the variables, go back to Excel. You see we have 4 variables: GDP, CPI, population growth, unemployment. So you go to the command, you type data, you give a space, GDP, CPI. CPI stands for Consumers Price Index. It's a proxy for inflation. GDP is Gross Domestic Product, proxy for economic growth, right? Population growth and unemployment. Once you, yes? There's no data? Okay. Then let's work with those 3. So now I have these 3 variables. Once you type in the command, you press enter, you see the spreadsheet opens on eViews. What you need to do now is you go to Excel, you copy your data. You copy just the data. You don't copy the years, you don't copy the variables. You copy just the data. So what I do, there are many ways to copy, but what I do is I click on the first cell here. That's the first cell. I scroll down and I have to click on the last cell. But before I click on the last cell, I hold Shift on my keyboard and I click it, highlights all the data. Then to copy, Control C. I go back to eViews and I paste. You have to paste in the first cell. If I paste Control V, right, I paste the data there. Now I have pasted the data. Once I have pasted the data, it means the data is on eViews, right? So that is how we import. So you can just close this. They'll tell you, do you want to delete? Take yes, no problem. If you look here, you still see the variables here. So I have already brought in the data to eViews. That is how we import time series data. Okay, before I work with this data, I'm going to show you how to import cross-sectional data because it is different. So I'll delete this, save no. Let me just close the whole. I've closed eViews. Now I'm going to cross-sectional data. This is our cross-sectional data. By the way, when you download the data from Excel, from data bank or wherever, it will not really come in this format. It might come in a vertical format, but like I told you, you have to transpose the data, like you copy and paste with the transpose option, so that it should come in this vertical format rather. Because if you download it, it will come in a horizontal format. Those who have not watched the video might not know how to transpose the data. So go back and watch the first video. You understand what I'm talking about. So in this cross-sectional data, we have 2 variables, GDP and CPI, right? Now, with cross-sectional data, since we are not using years, with time series data to input in eViews, you need to know the start year and the end year. But with cross-sectional data, we are not using years because we have just 1 year, 2017. So we instead need to know the number of observations. So how do you know the number of observations? Go down and check. The last data is at 34, which means there are, I think, 32 observations because the first 2 rows are something else. So the data starts from the row 3 till row 34. So there are 32 observations, right? Okay, I'm opening eViews. Since it is cross-sectional data, I'm starting new. Since it is cross-sectional data, we are not going to use dated. You take unstructured, undated. They are asking you number of observations, 32, right? Once you click 32, you press OK. Sorry if I'm going too fast. It's because I have just 1 hour. And I feel like there are so many things I have to say. So if you go and watch the video, you might understand. And even after 1 hour, if I don't finish, I will leave you to go, but I will continue recording so that you can watch it later. I asked them to give me 2 hours, but they gave me just 1 hour. I don't know why. So now this is cross-sectional data. Again, I go to the command. I have to type in my data. Data. We have just 2 variables here, GDP and CPI, right? So in the command bar, I'll type in data, GDP, CPI. Once I press enter, you notice what happens. You see the work file. It is slightly different from the work file we saw with time series. In this work file, we are seeing 1, 2, 3, 4, 5, 6. Can you see it here? Numbers. With time series, we saw the years, 1991, 1990, 90, you understand? But this one, we are seeing the numbers, 1, 2. So you need to know what each of these numbers mean. Like when you're reporting your analysis, you need to define that this number stands for this country. No, you can't put countries here. These numbers represent a country. You go, if I come back to Excel, you see here Afghanistan is number 3, right? So you will say number 3 stands for Afghanistan. You see here Belgium is number 16. So number 16 stands for Belgium, right? So each cross section will be defined by a number. So when you see the graph, you will not see Afghanistan on the graph, you will just see number 5. Then you need to know what number 5 is. You need to know number 5 is this country. So when you're explaining your results and you see 5, you know that 5 stands for this country. Does that make sense?
Yes, but there's no way you can put the name of the country.
Maybe with other softwares, but with eViews, I'm not so sure. I used it a lot. I represent it by numbers. That is the way I was taught as well. Okay, so at that stage, it is the same thing. You want to now send the data from Excel to eViews. You just copy the data, like I always do. Just copy, come back to eViews, and you paste. Always make sure you paste in the first cell, right? So once you have pasted, you can now delete it. And you see that is the data there. We have CPI data, GDP data. So that is how you can import data from Excel to eViews, whether time series or cross-sectional. Okay, now I'm going to delete this cross-sectional and go back to time series. Then I can show you what I want to show you because I like working with time series data. So don't save. So I'm deleting everything. I'll open back eViews. I'm going to do it very quickly. Annual, I think, was it 1991 to 2019? Let me just check. So the time series data, 1991, 2019, okay. So command, data, GDP, CPI, population, growth. Unemployment is not, there's no.
Yeah, the section in the Excel is information technology.
We have no data for unemployment, so let's just work with those 3 variables.
Like GDP, CPI, line, population, unemployment.
So we have GDP, CPI, population growth.
Yeah, what about?
Yeah, this unemployment, forget about it.
No, we haven't
Section
got
D.
the section. Yeah, section
There is
D.
no label.
Sorry?
If you look at D, there is no name under it. Does that make sense? D is GDP, C is CPI.
I think you forgot to merge the.
I see.
Yes.
Probably.
Unemployment revenue.
I get. Okay. It's fine now, right? Okay. So it means I'll go back to e-views and add unemployment. Delete yes. Employment. Okay. I think that's fine. So I'll copy my data. And paste in eViews. Again, always make sure you are pasting in the first cell. Very important. After pasting, you can delete. The data is there now. Okay, now there are many things we can do with this data. The first thing I'm going to show you is the graphs. Let me write something. Before showing you what I want to show you, I just want to make a difference between three concepts. There are three concepts which are very related, but they are different. Okay, we have correlation, regression. You will do regression next week with Gaussian. We have correlation, regression, and causality, or you can also call it causation, something. Actually, these three terms all talk about relationship. All of them talk about relationship. For instance, let's assume we have two variables, y and x. Two variables, right? Two variables. So correlation talks about the relationship between y and x. Regression talks about the relationship between y and x. Causality, or you can call it causation, talks about the relationship between y and x. So all of them talk about relationship. But then what is the difference? I can say this correlation of all three, correlation is the weakest. Is the weakest relationship, while causality is the strongest relationship. So regression is like in the middle, right? Now, what do we mean by correlation is the weakest relationship? It is because correlation just tells us whether these two variables are related or not. That's all. Is there a relationship between y and x? Is the relationship strong? Is it weak? Or is it medium? Right? So with correlation, it tells us if the relationship is weak, strong, or if it is medium. So that's the only thing correlation tells us. These two variables, are they related? Okay, fine, they are related. Is the relationship weak? Is it strong? Is it medium? That's all. Now we have what we call the correlation coefficient. This correlation coefficient ranges from 0 to 1. It is either 0 or it is in between or it is 1. It ranges from 0 to 1. Now, from 0 to 1, what do we have in the middle? 0.5, right? Then let's say here we have 0.3, here we have 0.7, right? If the relationship, so the correlation coefficient can be, and again, this correlation coefficient can be positive or negative. So if the correlation coefficient is positive, it means there is a positive relationship. If it is negative, it means there is a negative relationship. But then how do we know if the relationship is weak or strong or medium? If the coefficient is greater than that is from 0.7 to 1, then it is a strong relationship. If it is from 0.3 or less than 0.3, it is a weak relationship. Then if it is between 0.3 and 0.7, it is a medium relationship. So for instance, if you have a correlation coefficient of let's say 0.8, it is a strong relationship because it is bigger than 0.7. If you have a correlation coefficient of let's say 0.2, then it is a weak relationship. If we have 0.4, it is a medium relationship. Does that make sense?
Yes, but what about positive and negative?
It can be positive, you can have negative 0.2.
It has just a less than 0.
I'm talking of absolute terms here, right? So if it is negative 2, when you take the absolute value, it becomes 2, right?
Yes,
so in absolute value, it
when
is
you
between
draw them,
0
there is
and 1.
something about.
Sorry?
When we draw them, it's.
No, nobody will ask you to draw them. I'm just demonstrating.
I think.
I'm just telling you that correlation coefficient, you can have 0.2 and you can still have negative 0.2, right? If you want to check if it is weak or strong, consider this negative 0.2 as 0.2. So look at it as 0.2. Therefore, it is weak relationship. But since it is negative here, you know that it is a negative relationship.
No, I think she was saying that if the scale would go on the left side of the zero, it becomes negative, right?
No.
It's absolute value.
Absolute value. It ranges from 0 to 1. It can be negative, it can be positive. So if it is negative, then it is a negative relationship. If it is positive, it is a positive relationship. Then if you want to check whether it is
that's what I
weak,
was talking about. Saying,
if you want to check if it is weak or strong, then get the absolute value.
Yes, but also with negative and positive, you can see that there's a strong but opposite or something like that. I remember.
I don't understand
I
what you
think
say.
it's trying to say that if it's a negative relationship, it means the two variables are moving in opposite directions.
Exactly.
I'm going to show, I'm going to demonstrate.
It's
I
like
understand. Okay.
positive and moving in the same direction.
Okay.
But it depends on how strong.
Now, so that is it about correlation, right? And by the way, positive negative relationship. If we have two variables, let's say this is GDP, this is trade. If GDP is going up and trade is also going up, then there is a positive relationship. Then if GDP is going up and trade is coming down, then this is a negative relationship, right? So positive relationship, they go in the same direction. Negative relationship, one is going up, the other one is coming down. Okay. So that is regression, correlation. The next one is regression. So you discover that correlation tells us just if there is a relationship or not. Is it strong? Is it weak? Right? Regression goes a step further. With regression, we also look at the relationship, but regression discriminates the variables in terms of importance. What do I mean by discriminate? Like regression tells you this one is dependent variable, this one is independent variable. So for instance, regression can tell you that y is dependent variable and x is independent variable. Therefore, if we want to look at the relationship between these variables, we need an equation, right? So we can have an equation like this: y equals a plus bx plus c. Just example. Or if I can use, let me use beta 0, beta 1, and let me use here U. So with regression, we are also looking at the relationship between variables. But now regression, like says this one is dependent variable, this ones are independent variable. So it discriminates between the variables. So if y is dependent variable, then y will be a independent variable on the left. Then this x is independent variable, right? This is a constant. This one is the coefficient of this variable, and this one is error term. U in some books may use E. So you discover that regression also talks about relationship, but now it discriminates between the variables. So you start regression is stronger than correlation. Correlation is the weakest. And if you go a step further, causality or I'm not even sure we have time. Causation. Causation now goes a step further. That's why causation is the strongest. What do I mean by a step further? Now, if we have the same equation, with causation we have what we call cause and effect relationship. Cause and effect relationship. For instance, with regression, regression just tells us that y is dependent, x is independent. Therefore, what does it mean? It means y depends on x. That's all regression tells us, that y depends on x. Actually, y can depend on x, but it doesn't mean that x causes y. For instance, if I can give you an example, if you plant something, if you plant crops, when rain falls, the crops will grow, right? So let's say I want to look at the relationship between crops and rain. Now, with regression, regression will tell me that crops is dependent variable, rain is independent variable, which means crops depend on rain. And actually, if you look at causation, you discover that rain causes crops. Why? Because when rain falls, crops grow. So crops is because of rain. So there is like a cause and effect. What is the cause? The cause is the rain, and the effect is the crop. Then the other way around cannot go. You cannot say crops causes rain. You cannot say rain falls because of crops. Then you can say crops grow because of rain. Does it make sense? Yeah. So it's getting confusing for you, I'm sure. If you have crops and rain, if we are looking at correlation, let's say we have the correlation coefficient is 0.8. 0.8 means strong relationship, right? So correlation, it will just tell you that there is a strong relationship between crops and rain. That is all correlation will tell you. Now with regression, it discriminates. It tells you that crops is dependent variable, rain is independent variable, which means crops depend on rain. So when we get the coefficient, we will just analyze it by knowing how much of rain affects crops. That's all we'll get. Then we will not know if there is a causal relationship between crops and rain, right? So with causality, we check cause and effect. The question we are asking is, this variable, does it cause this other variable, right? Does rain cause crops? Yes. Then does crops cause rain? No. Yes.
Just like the first one, it also have positive negative relationship.
Of course, all of them have positive negative. Like for instance, this variable here can be negative. If it is negative, it means x has a negative relationship on y. If it is positive, it means x has a positive relationship on y. All variables, it can be positive or negative, but I'm just explaining the difference between them. Okay.
And then causality, is it always the, in this case, or one side can cause the other?
No. It can go both sides. with causality, if it goes both sides, if crops cause rain and rain also cause crops, then we call it bidirectional. We call it bidirectional causality. Then if it goes just one side, like rain causes crops, but the crop does not cause rain, we call it unidirectional causality. If you take this course in a 514, it's an elective course, and it's the guy who teaches it, you understand all of this, you will help you a lot. Okay. Let me show you the graphs. I'm not going to have time. So what will happen is that when it's time you will go, I'll record myself and I'll send the video. So now we have these variables on e-views. So let's assume that our dependent variable is GDP. If our dependent variable is GDP, then how am I going to write the equation? Can I write it? So we have four variables, right? Our dependent variable is GDP. So we'll write like this: GDP equals a constant first. Always start with a constant. Beta 0 plus beta 1 CPI plus beta 2 population growth plus beta 3 unemployment plus error 10. So this is how we are going to write our equation. On the left hand side, you always have the dependent variable. On the right hand side, you have an independent variable. But it's good, you must not always put the constant there. It's good to put it. This is a constant term, or you can also call it the intercept. CPI, population growth, unemployment are the independent variables. These are the coefficients. Like beta 1 is the coefficient of this variable, beta 2 is the coefficient of this variable, beta 3 is the coefficient of this variable, and this is the error term. I explained last error term, right? I told you that there are many variables that affect GDP, not only CPI, population growth, unemployment. You can have hundreds, thousands of variables. But we cannot write all of them because our model will be too long and will make no sense. So we include this error term. This error term includes those other variables which affect the dependent variable, then which we cannot include in the model. So this is our model. Okay. Now, since we have our model, I think we have just like 6 minutes, no problem. So I'm showing you the graphs, GDP, population growth. By the way, it's always good to highlight your dependent variable first there. So I will highlight GDP. Just hold Control key. You hold Control key, and you choose the rest. CPI, population growth, unemployment. Once I've highlighted all four variables, you just press enter. You can see the data of the variables, right? You come to view, graph. Don't change anything. Come to the last n year. Take multiple graphs so you can see all the graphs at once. And then take OK. You see the graphs, right? Now, these are the graphs. You can explain these graphs. And I told you that, I'm just repeating these things. I told you last time that when you have to explain these graphs, you have to explain it from the perspective of the dependent variable. Our dependent variable is GDP. So you look at GDP graph first, then you can explain these other three graphs from this one's perspective. And when you are explaining these graphs, you must use the word average. Because, for instance, you see here, it goes up, it comes down, goes flat. So it's going up, coming down. So you cannot say it is going up without using the word average, right? Even though here it is going up, coming down, but on average, it is going down. Because you see, it is going down. But it is on average. Why? Because there are times when it goes up. So always use the word average. So if I'm to extend this graph, I will say there is a negative relationship between CPI and GDP. Why negative relationship? Because GDP is going up on average, while CPI is going down on average. I told you when they go in different directions, it's negative. If this CPI was also going up, it would have been positive relationship. So there is a negative relationship here. But then how do you explain it? You cannot say as GDP goes up on average, CPI goes down on average, therefore negative relationship. That is wrong. If you explain it that way, it is wrong. Why? Because you are trying to make it look like CPI depends on GDP. You are saying as GDP goes up, CPI goes down. So you are making it sound as if GDP first of all goes up and then CPI comes down. If you say it that way, then you are indirectly saying that this is dependent variable and this is independent variable. So since GDP is dependent variable, we have to start explaining this one. So what you will say is that on average, CPI graph is way down, while GDP graph is way up. Therefore, there is a negative relationship between the two, right? Yes. You have to first of all say what is happening to the independent variable, and then you explain how the dependent variable reacts. Because the dependent variable depends on the independent variable. And I'm going to give an assignment of this, so you have to explain it next in the assignment. To explain these ones where we have fluctuations is a bit difficult. Like you see here, it goes down, goes up. So we cannot see an average behavior. On average, we cannot see if it is down or up. Here too, we don't know if it is down on average. So this kind of ones, what you can just say is that there are fluctuations. There are fluctuations, so it is difficult to see the relationship. But we have ones which are clear. So that's how we can explain the graphs. The next thing I wanted to show you was descriptive statistics. And I think it's time. So I will let you go if you want to, but I'll continue recording. I will continue recording myself, what I want to tell you, and I will put the video there. You should watch it because I will have, when I get to the office this afternoon, I will prepare your first assignment and I will send. You should do the assignment and send to me before next class. Next class is on Tuesday, so you should do the assignment latest Monday. You understand? You send to me. You can send on Teams or email. I prefer email. I will send my email. I'll send my email now to the group. Let me just send it now. Sorry? That I should send it early? I will send the assignment today. Anyway, since I'm still recording, if I forget, remind me. Somebody should send me a message on Teams. I will send my email address. So since it's time, you can go, no problem. But I will continue recording because there are still other things I want to show you. So I'll record. Then you can watch it.
Don't forget to add us on Teams.
I'll add. By the way, if you have any problem, if there's anything you want to ask me, if you can ask me on Teams, or you can come to the office, or you can meet Nigahoja. It depends on you. Okay, see you. See you.
Oh, okay.
Don't bother, I will make sure I add those who are not. Okay. Okay. So I'm just waiting for you to leave, then I continue the record.
I'm not sure if you can go to my laptop. I'm going to try today. No, it's not. So I'm going to try to work. I'm going to send it to you as well. If I make it work on my
Okay, see you. Bye bye. Bye bye. Bye bye. See you. Please, can you lock the door? Close the door. Thank you. Okay, guys. So now, like I said, I'll continue recording because there are other things I want to show you. But one eye is too small for me to show you everything. So this is how we'll be doing it. We'll come to class, I show you something. Then if I cannot finish, next class, or sorry, when you leave, I continue recording. You watch the video. If you don't understand anything, you can always ask me. You can come to the office. You can send me a message on Teams, or you can meet Nigahuja. Okay. Now I've showed you the graphs, how to explain the graphs. And again, I'm repeating, while explaining the graphs, you need to know what dependent variable is and what independent variable is. And you explain the graphs from the perspective of the dependent variable. That is, you have to first of all say what is happening to the independent variable, and then you say how the dependent variable reacts, because the dependent variable depends on the independent variables. Now, if one graph is going up and the other graph is coming down, then it is a negative relationship. If both graphs are going in the same directions, like both of them are going up or both of them are coming down, then it is a positive relationship. And like I told you, when you are analyzing these graphs, you have to use the word on average. So you have to say on average, this one goes up. On average, this one goes down. Therefore, negative relationship. Okay, so those are the graphs. I'm deleting it now. The next thing I'll show you again is descriptive statistics. So again, you highlight all your variables. It's always good to start with the dependent variable. So you first of all highlight GDP, you press Control key, you highlight CPI, population growth, and then unemployment. You press Enter, you come to View, and then descriptive statistics. With descriptive statistics, we have common sample, individual sample. It's always good to choose common sample so that it will give you the same observations for all the data. Common sample. Now, this is our descriptive statistics. We have GDP, CPI, population growth, unemployment. By the way, this GDP, gross domestic product, is like a proxy for economic growth. We use it to measure economic growth. CPI stands for Consumer Price Index, which is a proxy for inflation. We use it to measure inflation. Then we have population growth, and we have unemployment. So now we are looking at the descriptive statistics of these variables. We have the mean. This 7.11 raised to the power 11 is the mean value of GDP. While this 35.79 is the mean value of CPI. This 6.7 is the mean value of unemployment. So the mean value is like the average value. We have the median. The median shows us the middle value when you arrange all the data in either ascending or descending order, and you pick the middle value. That's the median. You have the maximum, which is the highest value in the series, the minimum, which is the lowest value, and then we have the standard deviation. How do you explain standard deviation? Standard deviation shows you the variability in the data. It shows you how the data points are far away from the mean value. So you know the mean value is like the average value, but there are some data points which will be above the average and there are some which will be below the average. So the standard deviation shows you on average how these data points are away, how they deviate from the mean value. We have the skewness and kurtosis, and we have Jagbera. Skewness, kurtosis, and Jagbera, these three, we use them to check the distribution of the data, to check if the data is normally distributed or not. Skewness and kurtosis will give you an idea, but we will formally check it using Jagbera. For instance, if the data is normally distributed, then the skewness value should be 0, which means it should not be skewed. So if the value is around 0, then it gives us a hint of normality. But if the value is different from 0, like far from 0, and again it can be positive or negative, then it gives us a hint of the data not being normally distributed. With kurtosis, for normally distributed data, the kurtosis should be 3.
So if it is around 3, then we can say it is normally distributed. But if it is far from 3, then we can say based on this there is a hint of non-normality. But like I told you, we are not going to use skewness and kurtosis to say with certainty if the data is normally distributed or not. We need to carry out a statistical test, and the statistical test we are going to use here is the Jagbera test. Now, in the last class, I told you about Jagbera test, and I told you that, let me open Microsoft Word so I can write. Since I'm recording, you can watch it, because if I write on the board now, nobody will see. Now, for statistical tests, we use two hypotheses. We have the null hypothesis and we have the alternative hypothesis. This I said in the last class, so please watch the first video before watching this one. H0 stands for null hypothesis, H1 stands for alternative hypothesis. Now, each statistical test has its own null hypothesis and its own alternative hypothesis. But now for the Jagbera test, we use this test to test if the data is normally distributed or not normally distributed. So for this test, the null hypothesis is that the data is normally distributed. The alternative hypothesis is that the data is not normally distributed. So we need to know how to perform this test. To perform this test, we are going to use the probability values. Probability value. We can also call it p-value, or at times they call it prob value. It's the same thing. Now, when we have the probability value, we are going to look at it from 3 perspectives. We have levels of significance. I said all of this last class, I'm just repeating myself. We have 3 levels of significance. 3 levels. We have the 1% level of significance. We have the 5% level of significance, and we have the 10% level of significance. Now, if you are working on a study or you're doing something, you are supposed to use one level. Generally, we always use 5% level. Most studies or in most articles or anything, we always use 5% level. But the reason I'm showing you all 3 levels is because in some studies or at times you will see some people are using 1% level, some are using 10%, some are using all 3. So you can use all 3 or you can use one of them. But most of the times they use just 5%. What does it mean to perform a statistical test by using level of significance? You check the probability value. There are other things we can check, like when we'll start doing regression next week, we'll see that we can also check things like T statistics, and with the T statistics we'll need to know the critical values and stuff like that, critical values, to determine if it is statistically significant or not. But we are not using that today, so I'm deleting it. We are using just probability values, so I'm deleting it. Now, with the probability values, it can either be significant, it can either be statistically significant, or it can be statistically insignificant. Now, if it is statistically significant, then we reject the null hypothesis and accept the alternative hypothesis. If it is statistically significant, then we reject the null hypothesis and we accept the alternative. If we are rejecting the null, then we are accepting the alternative. If it is statistically insignificant, then we cannot reject the null hypothesis. So we do not even look at the alternative hypothesis. These things can be confusing if you don't follow it well. Okay. With respect to the null hypothesis, it is either we are rejecting the null hypothesis or you say we cannot reject the null hypothesis. We never accept the null hypothesis. So don't be tempted to say, okay, if we cannot reject the null hypothesis, therefore it means we are accepting the null hypothesis. No, we never accept the null hypothesis. The only time we use the word accept is if we are making reference to the alternative hypothesis. So we only accept the alternative hypothesis. We don't accept the null hypothesis. And the only time that we accept the alternative hypothesis is if we are rejecting the null hypothesis. So if you reject the null hypothesis, therefore you are going to accept the alternative hypothesis. But if you cannot reject the null hypothesis, then you don't even look at the alternative hypothesis. And again, if you cannot reject the null hypothesis, don't say that you are accepting the null hypothesis. No, just say that we cannot reject the null hypothesis. It ends there. I hope that is clear. Now, we have two hypotheses here, the null hypothesis and the alternative hypothesis. The null hypothesis says the data is normally distributed, and the alternative hypothesis says the data is not normally distributed. So, if we reject this null hypothesis, then we are accepting this alternative hypothesis. And if we accept this alternative hypothesis, it means that the data is not normally distributed, right? But if we cannot reject this null hypothesis, then it means that the data is normally distributed because we are not even going to look at the alternative. I hope that is clear. Now, when do we reject the null hypothesis and when can we not reject the null hypothesis? So, in this first case, we are going to reject the null hypothesis if the probability value is less than significance level. By the way, this significance level, they also call it alpha. So here we can say if probability value is less than alpha, or here alpha, in this case, think of significance level. So if your probability value is less than significance level, then we can reject the null hypothesis and accept the alternative hypothesis. And in that case, we are going to say it is statistically significant. But if the probability value is equal to or greater than the significance level, so if probability value is greater than or equal to significance level, then we cannot reject the null hypothesis. Therefore, it is statistically insignificant, right? Okay. Now that I've explained this, I'm going back to E-views. Remember, we are trying to perform the Jagbera test. So let's take the first variable GDP, and this is the Jagbera test statistic. Don't bother about this test statistic for now. Focus on the probability value. We can also perform this test using the test statistic, but today I'm showing you just probability value. So for GDP, the probability value of the Jagbera is 0.24. This 0.24 is like 24%, right? 24%. Let's go back to Word document. You see that we have 3 levels of significance, 1, 5, and 10. The probability value of the Jagbera for GDP is 24%. 24% is greater than 1%. It is also greater than 5%, and it is also greater than 10%. What does it mean? Come back here. If the probability value is greater than the significance level, therefore therefore it is statistically insignificant, and so we cannot reject the null. So for the GDP, since the probability value for Jagbera is 24%, which is greater than all these 3 significance levels, it therefore means it is statistically insignificant. It is statistically insignificant, and so we cannot reject the null hypothesis. So we cannot reject this null hypothesis. And if we cannot reject this null hypothesis, it therefore means the data is normally distributed. So the GDP data is normally distributed. That is our conclusion. And that is how you explain the Jagbera test. So we have concluded that the data is normally distributed. Okay, let's check probability value for CPI. You see that it is 16%, and here for population growth is 24%. 16% and 24%, both of them are greater than all these 3 significance levels. And since the probability values are greater than the significance level, it therefore means it is statistically insignificant. Therefore, we cannot reject the null hypothesis. And if we cannot reject this null hypothesis, therefore we are concluding that for both the CPI and the population growth, just like with the GDP, the data are normally distributed. That is fine. Okay. The last variable there is unemployment. Look at the probability value of unemployment. It is 0.00004, which is like 0%. And 0% is less than 1%. So it is 0%, which is less than 1. Because 0 is less than 1, right? So since the probability value is less than the significance level, it therefore means it is statistically significant. So we'll say here that since the probability value of unemployment is 0%, which is less than 1%, it therefore means it is statistically significant at 1% level of significance. Therefore, we are able to reject the null hypothesis. So we are going to reject this null hypothesis, and we are accepting the alternative hypothesis. So we are going to accept this alternative hypothesis, which says the data is not normally distributed. So the conclusion now is that the data is not normally distributed. So you discover that we have performed the Jagbera test, GDP, CPI, population growth. The data for these 3 variables are normally distributed. Therefore, unemployment, the data is not normally distributed. So that is how to perform the Jagbera test. So while explaining the descriptive statistics, you have to explain the mean, the median, the maximum, the minimum, standard deviation, all these things. And then when you come to Jagbera test, you have to perform the test like I've showed you. And to perform this test, you need to write down the null hypothesis and the alternative hypothesis, and you have to explain to me what is happening. You look at the probability value. Is it less than? Is it greater than? Is it significant? Is it insignificant? Can we reject the null? Are we accepting the alternative? You have to explain all of that. So that is how we explain. Then here we have the sum. The sum is just like if you add up all the values, the data, that's what you get. We have the sum squared deviation. We have observations like the number of data. We have 29 observations. Okay, so that is it for descriptive statistics. I will delete it now. Okay, after showing you descriptive statistics, the next thing I'm going to show you is correlation metrics. Remember in class I gave you the difference between these three concepts: correlation, regression, and causality. I told you that all these three concepts talk about relationship. Let's say we have two variables, x and y. All these three concepts will talk about the relationship between x and y. But correlation is the weakest, while causality is the strongest. Regression is like in the middle. Why is correlation the weakest? It is because correlation only tells us if there is a relationship between the variables. It only tells us if there is a relationship between x and y. Is this relationship negative or positive? Is it a strong relationship, or is it a weak relationship, or is it a medium relationship? That is all correlation tells us. But regression goes a step further by discriminating between the variables, like telling you that this variable is dependent variable and this other variable is independent variable. Therefore, if we know the dependent variable and the independent variable, we can write the regression equation. Y equals like beta 1 plus beta 2 x1 plus beta plus y equals beta 0 plus beta 1 x1 plus beta 2 x2 and so on plus u, right? So that beta 0 is like the intercept or the constant. U at the end is error term. So we can write out the regression equation. Now, causality or causation goes a step further by checking if there is a cause and effect relationship. So it does not only tell us that x affects y, but it tells us if x causes y or if y causes x. So is there a cause and effect relationship? And I gave you the example of crops and rain. For instance, if there is rain, crops will grow. So we can say rain causes crops, but we cannot say crops causes rain, because you cannot say rain is falling because of crops, right? So in this case, we have unidirectional causality because it goes one direction. Just rain causes crops, but crops does not cause rain, so it is unidirectional. But if it goes both direction, if y causes x and x also causes y, then it is bidirectional. I mentioned all of this in class. Okay, that was an aside. So I'm going back to correlation. So, like I told you, correlation just shows us is there a relationship between the variables? Is it positive? Is it negative? Is it strong? Is it weak? Let's check it. So we have these four variables: CPI, GDP, population growth, unemployment. I press enter. I come to view. Come here to covariance analysis. We don't want to check covariance. We don't want to check any of these things. We want to check just correlation. So remove this tick from covariance and tick correlation, then press OK. This is the correlation matrix. It shows us the correlation. And in this correlation matrix, we have correlation coefficients. All these values you see inside here are correlation coefficients. For instance, this negative 0.7 is the correlation coefficient between CPI and GDP. This negative 0.08 is the correlation coefficient between unemployment and CPI. This negative 0.14 is the coefficient between population growth and unemployment. And I told you that correlation coefficient ranges from 0 to 1. It can be negative and it can be positive. If it is negative, it means there is a negative relationship. If it is positive, it means there is a positive relationship. Now, is the relationship a weak relationship, or is it a strong relationship, or is it a medium relationship? How do we know? If I told you the coefficient is from 0 to 1, right? And for the negative values, look at the absolute value. So it should be from 0 to 1. Now, if the value is from 0 to 0.3, then we can say it is a weak relationship. If it is from 0.3 to 0.7, then we can say it is a medium relationship. If it is from 0.7 and above, like above 0.7, then we can say it is a strong relationship. So, for instance, if you look here, this is negative, therefore, we'll say there is a negative relationship between GDP and CPI. Here is positive, so there is a positive relationship between GDP and unemployment. Here, negative relationship, negative, positive, right? Okay. Now let's check those which are weak relationship, strong relationship, and medium relationship. If you look at this one, 0.19, like 0.19 is like less than 0.3. So it is a weak relationship. If you look at this one, 0.4, it is between 0.3 and 0.7. So it is a medium relationship. Here 0.85, or sorry, 0.08, so weak relationship. Here 0.74, it is bigger than 0.7, so it is a strong relationship. So in this case, we'll say there is a strong negative relationship between GDP and CPI. Here we'll say there is a weak negative relationship between GDP and population growth. Here there is a weak positive relationship between GDP and unemployment. Here there is a medium positive relationship between CPI and population growth. So that is how you explain the correlation matrix. You need to tell me the relationship between each of the variables, and you need to mention to me if this relationship is positive or negative. And you also need to tell me if the relationship is weak, or if it is strong, or if it is medium. Those are the main things you have to report while looking at the correlation matrix. And all these values inside this correlation matrix are correlation coefficients. Actually, they call them Hessing's correlation coefficient, because it was discovered by one scientist called Pearson. So they are correlation coefficients. Okay, I'm deleting it. So that is that about correlation metrics. So I've showed you graphs, how to interpret the graphs. I've showed you descriptive statistics, and we have checked the items, including Jack-Barrett test. We have checked the null hypothesis and alternative hypothesis. I've showed you correlation metrics. I've explained the difference between correlation, regression, and causality. One thing I'm going to show you now is data transformation. So I'm closing this. Okay, so let me delete this. What I'm going to show you now is data transformation. So we have, well, our data can be in raw form, or it can be in transformed, or we can transform the data. So let's say transform data. So we can have raw data and transform data. Raw data is the data we have in its original state. Like if you download the data from the database, the way it comes, you don't transform it the way it comes. That is raw data. So it's like original data, or you can also call it level data. Now, this data, this our raw data, if it is fine, if everything is okay with it, we use it that way. But most of the time, you discover that the data has some problems and you need to do some corrections. You need to correct these problems. So one of the ways of correcting these problems is by transforming the data. And there are many ways to transform this data. We can do logarithmic, or let me go down. Let me see, we can do logarithmic transformation, or you can say log transformation. we can get the first differences, and we can get the lagged form of the data. In this course, we are going to focus on I'll show you all three how to do it on eViews, but in this course, we are going to focus on this because we use it a lot. But in other courses, we can use this more often. So now, logarithmic transformation. Actually, we use natural logarithms here, natural logs. These natural logs, we call it ln. Ln stands for ln. So with a log transformation, we mostly do natural logs. I'll show you how to do it on eViews. And there are many advantages of using log transformation. There are many reasons why we might want to use logs. Let me see. Advantages of log transformation. One of the reasons why we use log transformation is because of easy interpretation and analysis in percentages. If we can have variables with different units, for instance, if we have like our data here on Excel, we have GDP, CPI, population growth, unemployment. These variables can be in different units. But so while if we are using the original data, that's level data, raw data, while interpreting it, you have to mention the units of each variable, which might be kind of complicated or maybe difficult. So if we are using logs, it makes our life easy because logs will express all the variables in the same units, which is in percentages. So while interpreting the data, we are using the same units for all the variables. So we are interpreting everything in percentages. So that's one of the main uses of using logs. It expresses all the variables in percentages. So it makes it easier for us to analyze and interpret our data. Another reason why we can use logs is because it solves some problems with the data, some problems like normality, heteroscedasticity, etc. These are assumptions. We are going to see them subsequently, but for now, just try to know that heteroscedasticity is a problem with data. Like if your data is heteroscedastic, it simply means the variance of the error terms are not constant, right? So it is a problem with this data. So maybe if we try to take the logarithmic form, the natural logarithm of this data, if we do log transformation, it might solve this problem. It is not a guarantee. We can still take log transformation and it does not solve the problem. But at times, it helps to solve this problem. Also, if your data is not normally distributed, at times, if you take log transformation, it makes the data to become normally distributed. So it solves that problem. And I've showed you how to test for normality using Jagbera tests. So log transformation helps to solve some of the problems with the data. So these are like two uses of taking logs. There are many other uses, but these are the main ones. Okay, so we are going to see how to transform our data. Again, our data can be in raw form, or we can transform the data. Now, we are going to see these three types of transformation. So the first one I'm going to show you is log transformation. Okay, I'm going to eViews. So this is our data we have imported in eViews. We have GDP, CPI, population growth, unemployment. Okay, it just escaped my mind. Let me just write it down. We have a third reason why a third advantage of log transformation, it rescales the data and reduces the variability. So if you take log transformation, it rescales the data and it reduces the variability, and this is what actually solves the heteroscedasticity problem. I'll show you on eViews what I mean by that. Okay, I'm going back to eViews. Now, you see we have CPI data, GDP, population growth, unemployment. These are all raw data. This data, we just downloaded it from World Bank, put it in Excel, and then arranged it on Excel, and then imported it to eViews from Excel. So it is the raw data. We have not done anything with it. Now, let's generate the logarithmic form of this data. So you come back to your command bar, you type here GEN arrow. It stands for generate. So when you type generate, you are telling eViews, it's a command, you are giving eViews this command, and you are telling eViews to generate something. Up here with the first command we gave, the command was data, and then we just typed out the variables. So this command simply, when you write data, you are telling eViews that you want to input your data. So this second command, GEN arrow, stands for generate. You're telling eViews that you want to generate something. So we want to generate the logarithmic form of each of these variables. We'll start with GDP. So we'll say lean GDP, lean, I told you it is natural logarithm, equal log, open bracket, GDP. So you just type this. What does it tell you? GEN arrows. You are telling eViews to generate, and you are telling eViews to generate a variable called lean GDP, and you are telling eViews that in order to generate this variable, they should use this formula. They should actually take the log of GDP. So once you get to the end there, you press enter and you generate it. So you come back here, you discover that this is lean GDP. We have generated the logarithmic form of GDP, right? So we can generate for the other variables. So GEN lean CPI equal log CPI. Let's enter. So you can do it one after the other for all the variables, but in order not to waste time, maybe in an exam you need to be fast, you can just do one and then you keep changing, editing. Like for instance, let's say I've done this CPI and I want to generate the logarithmic form of population growth. If I don't want to repeat the steps, I just come here, delete this CPI and just type population growth. Then also come here, delete CPI and just type population growth. Then put your cursor at the end after the bracket and then press enter. It generates that of population growth. So this is population growth, lean population growth, lean GDP, lean CPI. So let's generate that of unemployment. Let me do it down because I want to show you something, and I specifically chose this data because I wanted to show you something with unemployment variable in particular. So generate lean unemployment equals log unemployment, close bracket, press enter. If you press enter, you notice something. They tell you that the log of non-positive number missing data generated. What does it mean? It simply tells you that in your series, there are some numbers which are not positive. Why? Because the logarithm of a number which is not positive does not exist. We can only have the logarithm of a positive number. If a number is negative or if a number is 0, then we cannot take the logarithm. We can only get the logarithm of a positive number. So if I come back here to my data on Excel, if you look at the data of GDP, all the GDP data, that is all this GDP data, you discover that there are only positive numbers. So that's fine. If you look at CPI, go right down, there are also only positive numbers. Population, only positive. But when you come to unemployment, you discover that this is a negative number, this is a negative number, this is a negative number. So there are negative values in the unemployment series. So when we want to take the logarithm of unemployment, E-views tells us that we are going to have missing data because we are trying to take the log of a number which is non-positive, right? So if you click OK here, then you will have missing data. Let me show you. Let me click OK. I've clicked OK. They have generated a series. This is the series, lean unemployment. Let me open the series. I click on it, I just press enter. Okay, if you come to this series, you see here non-available, non-available, non-available. This non-available means that there is no value there. Why? We have lost the value. Why do we lose the value? Let me go back to the original data. You see here, in 1991, we had negative value. In 2000, we have negative value. In 2009, we have negative value. Go back to e-views. In 1991, we have non-available. In 2000, we have non-available. In 2009, we have non-available. So whenever you have negative numbers or numbers which are equal to 0 in your series, and you take the logarithm, you are going to lose some observations. Some of your observations will become non-available, which means there is no data there. And if I show you the graph, let me just show you the graph of this series. Look at view, graph, graph. You see the graph, right? You see there are some breaks. You see a break here, you see a break, you see a break. These breaks are because we have lost some values, and the reason why we lost some values is because we had negative numbers in the series, and when we took the logarithmic form of negative numbers, we lost the numbers because the logarithm of a negative number does not exist. The logarithm of 0 is undefined. We can only take the logarithm of a positive. So that is it. I'm deleting it. Look at the original series on employment. Let me open it. Look at the graph. Graph. You see the graph is continuous, right? There are no breaks. But by the time you take the logarithm of this series, since this series includes negative numbers, you lose some values because the logarithm of a negative value does not exist. So how do we solve this problem? This is a problem, right? We have to solve it. Are you going to use graphs which have breaks? No, you have to solve it. So we are not going to rely on this one. So this lane that I took here, this log of unemployment, I'm going to delete it. So just come highlight it on your keyboard, right click, and then come to delete. Delete, yes. So I've deleted it because we are not going to use it. I just showed you to demonstrate. So now I'm going back again. Let's see. Oh my God. Let's say I want to generate the logarithmic form of unemployment, lean unemployment. If I press enter, oh, it's not defined. It's supposed to be log here, not lean, log. If I press enter, again, if use tells me log of non-positive number, because with unemployment series, as I've showed you before, there is a negative number, right? So if we want to take the log, we have missing data. So then how can we solve this problem? How can we take the log when we have negative numbers? It's very easy. What you can do is you go back to your series, try to look at the negative numbers and look at the highest negative number. So here you see here is -8, here minus 6, here minus 12, scroll down, that is minus 12, and here minus 9. So you discover that this is the highest negative number, right? So the highest negative number is negative 12. So you go to your series, try to observe the variables and identify the highest negative number. If it is negative 12, once you identify the highest negative number, then use a positive number, which is a positive whole number, which is just above the highest negative number. For instance, our highest negative number here is 12, negative 12. So we can use 13 to solve the problem. I'll show you how to solve the problem. So you identify the highest negative number, and then you use a positive number to solve the problem. How are we going to choose the positive number? Choose a positive number which is just above the highest negative number in absolute value. Like this is negative 12. If we take the absolute value, it becomes 12, right? Like 12.5, 12.552. So 13 is good because the next whole number is 13. So we can use 13. So identify the highest negative number. You get the absolute value of that number, so it becomes 12.552, and then take a positive whole number which is closest to it. So we are going to use 13 to solve the problem. I hope that is understood. Now, I'm coming to e-views. How are we going to use 13? So don't click OK, cancel it. How are we going to solve the problem? You come here in this series, you add plus 13, and then you come outside, you take minus 13. So once you have identified 13, you add it inside the bracket, and then you subtract it back outside the bracket. Once I click enter, you see I've generated the series, and e-views has not told me that there is missing data. This is the series here, lead unemployment. So you discover that I have been able to generate the log of unemployment, but without losing variables. Let me open it. Discover that, have you seen, there are no NAs, there's no missing variable. And if I show you the graph, you discover that the graph is continuous. There are no missing variables. So that is how we can solve the problem of logarithms when we have numbers which are not positive. Okay, now let me show you something with between raw data and log data. Let's choose one. Let's say GDP. Let's choose GDP. We have the raw data here, GDP, and we have whole control, and we have lean GDP. So this GDP is the raw data, and this lean GDP is the logarithmic form of the data. So I've selected both variables. Press enter on your keyboard. You see this is the data for both of them, GDP, lean GDP. Come to view, go to graph. I just want to show you something. Come to multiple graph so you can see both of them together. You discover that the two graphs are similar. They are almost the same, right? So if you take the log form, if you log transform the data, it does not really change the structure. It is the same. The graphs will remain more or less the same. It just rescales the data, and I'll show you. Okay, that's for GDP. Let's check, let's say population growth. This is population growth raw data. This is log transform data. I open both of them. I go to view, graph, come to multiple graphs so you can see both of the graphs at once. You discover that it is the same. This is the population growth series, and this is the log of the series. So you discover that the graphs are similar. They are almost the same. So don't feel like if you transform the data logarithm, if you take the log transformation, it will change the structure. No, the structure will be the same, more or less the same. But come back here, I was telling you advantages of using logs. And one of the reasons I told you is that it rescales the data and reduces the variability. Let me demonstrate. Now, this is a level data, raw data. You discover that, look at the scale. It is from 1.1 to 1.8, right? So the range is like 1.7. 1.1 to 1.8, yes. The range is like 1.7, which is like, I don't know. But look at here, -1 to -6. So you discover that the scale is different. It rescales the data. Let me show you another one. It's not so clear with this one. Let's look at CPI. Let's look at CPI and lean CPI. That is the raw data and the log transform data. If I open the graphs, come to graphs, come to multiple. So you discover that it is like the graphs are more or less the same. Yeah, maybe we have some fluctuations here, but on average, the graphs are more or less the same. So when you transform the data, the graphs are more or less the same. So what happens is that, look at the raw form CPI. It ranges, the scale is from like 0 to 120. So the range is like 120. But here you see the scale is just from 1.5 to 5. So the range is just like 3.5. How do you get a range? Highest value minus lowest value gives you the range. So here, highest value 120, lowest value 20, 0. So 120 minus 0 is 120. So the range is 120. But here the range is just 5 minus 1.5, which is 3.5. So you discover that with this log, with the, oh my God, what have I done? Sorry. You discover that with the log form of the data, we have a smaller range, while with the original form, we have a bigger range, but the structure is more or less the same. So by taking the log, it rescales the data and reduces the variability, and this helps to solve some of the problems with the data, like heteroscedasticity. So that is it. So actually, that is that about log transformation. Okay. Let me show you now the next. Let me come to. So I've showed you log transformation. Let me show you how to take first differences and how to do lagged form on e-views. Nigao just said I should show you that. Okay, so actually, I'm deleting this. We have our data. Now, how do we generate lagged form? I'm coming to command. You type in command again, generate. So let's say we want to get lag 1. Let me write something on e-views. I will do this. Lag form data is previous value of the variable. So for instance, let's say we have GDP variable, and we have this year's GDP. This year's GDP, we can just call it GDP. Last year's, if we want to look at last year's GDP, if what that is GDP of last year, that's previous period GDP, then we can say it is lag 1 of GDP. So when you hear of lag 1, it means previous one period behind last year, right? And how we can write it, we can just write it as GDP open bracket -1. So when you see GDP minus 1, it means lack 1 of GDP, that is 1 period backwards. We can have 2 periods backwards, like last year was 2021, so we can have 2020 GDP. So let's say, for instance, we can have lack 2. So we can have lack 2 of GDP, which we can write it out. We can just write it as GDP minus 2. So when you see GDP minus 2, it means lack 2. GDP minus 3 means lack 3. GDP minus 10 means lack 10. GDP minus 1 means lack 1. Okay, so how can we generate the lacks of a series? Like we want to transform to get a lagged form on e-views. So let's say this GDP, the raw form, I'm talking of the raw form, I'm not talking of this lean is the log transformed form, but I'm coming back to the raw form. So I want to get a lag, let's say like lag 1. So I will say generate lag GDP equal, well, okay, let's say equal, why did I use capital letters? Let me use small letters. Like GDP equal GDP open bracket -1. So I told you that when you see like -1, it means lack 1. If you see -2, it means lack 2. So if you press enter, this series, so this is like lack 1 of GDP. This series, lack 1. But if you want to get lack 2, then we would have instead put 2 here. If you put 2 here, then you just like press enter, it will give you lack 2. But in order not to confuse it, you can just call this one lack 2. You can come and put 2 here so that you know that it's lack 2. So you press enter, it gives you lack 2. So you see this is the lack 2 series. If you want to get lack 3, you can just come here, you change it to 3, and then you come here, you change it to 3. Put your cursor at the end and press enter, it gives you lack 3. So this is how we can get the lacks, like previous periods of the variables. Okay, let me show you what next. So I've shown you log form, log transformation, and lag form. I'll show you now first differences. Before show, let me delete this. Before show you first differences, I want to show you something like S difference is equals to level data minus lag 1. Like that's a formula. So to get the first difference, we need to get the level data, which is the raw data, right? And then we need to generate lag 1 of the data. Then we'll use this formula. Level data or raw data minus lag 1 will give us the first difference. But this is if you want to do it manually. If you want to do it on e-views, it's very fast. You don't need to follow all these steps. You don't need to say you get lag 1 first, and then you come and subtract lag 1 from level data to get first difference. On e-views, you just use the command. But I'm just showing you the formula so you should know what first difference is. I've told you what lag 1 is, like previous period, 1 period. I've told you what level data is. So first difference is like taking level data minus lag 1. You should know that. But on e-views, we can do it very fast using the command. So to generate the first difference of, let's still use GDP. So I'll just say like generate D. This D stands for difference, right? So I'll just say D GDP, which is equals to D open bracket GDP, and then you press enter. So this is where is it? D GDP. This is it. So this is the first difference. It's like the difference, the first difference. So that is how we can generate the logarithmic form, lag 1, and the first difference. So that is how we can transform our data in these three forms. Okay, I'm deleting it, deleting all of this. Okay. So I've showed you that. What next am I to show you? I hope I showed you everything. I just want to make sure I show you everything because I want to give you an assignment, and next class I want us to do regression. Okay. Yes, I've showed you lab, first difference, logs, graphs, descriptives. Okay, so basically I've showed you all the main things. So in your assignment I'm going to provide you with data like this, time series data, not cross-sectional, or I'm not going to provide you with data. I want you to download the data yourself. In the first class, I showed you how to download data from Wellbank. You transpose the data on Excel and you import it to eViews. So I'm not going to provide you data. I'm just going to provide you the names of the variables so that you yourself will go to the data bank, Wellbank, you download the data yourself in Excel. The data will come in a horizontal format. You have to transpose it into a vertical format, and then you have to import it to eViews, and then you do what I want you to do. Well, I think I'm going to show you again. Before I stop recording, I will show you again how to download it for those who watch the first video and not understand. So that when you watch the second video, you are going to understand. So that is what I'm going to show you. After you have downloaded the data and brought it to eViews, I'm going to ask you to input the data. So you will use this command, data and stuff like that. And I'm going to ask you to generate the log form, just logarithm. I'm not going to ask you about lags or phase differences. I'm going to ask you to generate just the log. And in case there are negative values in any of the series, any of the variables, you need to know what to do. Like here, I've showed you. So you are going to generate the logs. I'm also going to ask you to show me the graphs. So you show me the graphs and you have to analyze the graphs. So what you do is that you draw the graphs on eViews, then you copy the graphs and paste on Microsoft Word, and then you analyze. Let me show you how you can copy. For instance, let's say I want to draw the graphs of GDP, population growth, CPI, unemployment. Highlight, press enter, come to views, come to graphs. Sorry, I made a mistake. Come to view, come to graphs, come here to multiple graphs. Okay, these are the graphs, right? You have to copy these graphs and paste on on Microsoft Word, and you explain the graphs. So how do you copy the graphs? Just put your cursor there, click here, then just click here, then take Control A. Control A means you copy all of them, and then take Control C, copy, come to Microsoft Word and paste Control V. You paste with Control V. So those are the graphs. So you can copy from eViews and paste on Microsoft Word, and then you can analyze the graphs and everything. So that's how you can copy. After doing the graphs, let me delete. You also have to explain me the descriptive statistics, and so I press enter. I go to view. I come to descriptive statistics. I take common sample. So again, just take Control A, copy. When you choose copy, they will ask you, do you want to copy as displayed or do you want to copy using highest precision? Always take as displayed, so don't change anything, just take OK. So you have copied it. Go to Microsoft Word and paste. So you can paste it down here. Paste it here. So you can paste here and you can explain. And you also have to demonstrate, explain to me the Jagbera test, how you have decided whether it is normally distributed or not. Again, I'm deleting. I also want you to explain to me the correlation matrix. So again, I press enter. I go to view. I come to covariance analysis. I remove this covariance and I take correlation. I press enter. This is the correlation matrix. So you take Control A, then you take Control C, copy, come and put as displayed, copy as displayed. Okay. You come to Word file and you paste, Control V. You paste it and you explain. Explain to me the relationship between the variables. Is it positive? Is it negative? Is it strong? Is it weak? Is it medium? And why? So basically that is it. Those are the kind of things I'll be asking in the assignment. So that is all the main things I've showed you for today. So just as a recapitulation, I'm going to show you again how you can download data from Wellbank and import it to eViews. So I'm closing everything. And in fact, I'm closing my eViews totally. Save, no. Close. I've closed my eViews totally. Let me close Microsoft Excel so that I have no data. I want to download new data. Don't save. Don't save. Okay, so I've closed Excel, I've closed eViews. Now, how can you download data from data bank? Just come to search and type Wellbank data bank. Press enter. Come here, data bank, Wellbank. Data bank, Wellbank. So now I'm going to tell you what data to download. Now you come to indicators, choose this one, choose this first one, GDP growth. Oh, click on it. Like click on this first one. I'll tell you why. The network is slow. Like click on this first one. Oh my God. The network is slow. If I cannot do it, then you go and watch the first video because I explained in the first video, but the network, I don't know why whenever I want to do this, the network is disappointing me. Okay, so when you click that first one I showed you, it brings you here. Why are you clicking? Why did I ask you to click that first one, GDP? It is because in Wellbank Data Bank, we have many databases. You see here, database, country, series, time. You see, we have many databases. Like if I click on database, oh my God, network is slow. Network is slow. If I cannot do it, I will just stop recording, but I did it in the first video, so you'll go back and watch it because I'm tired. Anyway, no need to show you database, but just know that in Wellbank there are many databases. One of the databases is known as Well Development Indicators, WDI, right? So you discover that year available, year selected. Selected one means we have selected one database, and this you will see the name here. Whenever you choose a database, the name shows here. So Well Development Indicators is the database that we mostly use. When you come to this page, before doing anything, always clear section. because you have some default data here. I don't know why it always comes, but always come to clear section. Clear section. Once you click on clear section, all of this has to be cleared, but the network is slow, so I don't know why it's not going. Click clear section. So we have to wait for the section to clear. So you clear section. So while waiting for the section to clear, you see like all this data we see here. Once the section clears, we will not see this data. While waiting for the section to clear, let me show you something on Microsoft Word. So in the assignment, I'm going to give you a model. For instance, I'll give you a model like this: GDP equal beta 0, actually like beta 0 plus beta 1. I think I'll give you maybe just two variables there. Beta 1 CPI. I like using CPI, but there are other variables we can use, plus beta 2 what variable can I give you? Okay, let's see. Gross fixed capital formation is a proxy for investment. Then plus, let's say something like this. I'll give you a model. What does this model tell you? It tells you that GDP is dependent variable, CPI and gross fixed capital formation are independent variables. Beta 0 is the constant or intercept term. U is error term. Beta 1 and beta 2 are the coefficients. Like beta 1 is a coefficient of CPI and beta 2 is a coefficient of GFCF, right? Okay, so I'll give you this model, which means I expect you to download data for three variables. You should download data for GDP, download data for CPI, and download data for gross fixed capital formation. Three variables you will download. So I'm going back. Clear section. It has not cleared. It's not going. The network is a mess. Okay, to make things easy for you, I'm going to download the data myself and I will provide you with the data. Then you can just work with it, because I'm trying to show you how to download the data. I showed it last class, but I'm trying to repeat it. But the network is not stable, so I'm not so sure everybody has understood how to download data. And because I don't want you to fail, I'm going to make your life easy. So I'm going to download the data myself and then give you the data. So the only thing I want you to do is just for you to import the data from Excel to eViews and then work with it. So I'm going to do that. Don't bother. So just as an aside, let me just tell you some extra things just for your records. So like here, GDP is a dependent variable. GDP is the dependent variable. There are other names we can call dependent variable. Dependent variable, we can also call it regression, or we can also call it the explained variable. Yes, CPI and gross fixed capital formation are the independent variables. We can also call them the regressors, or we can also call them the explanatory variables. So if you see regressors, know that they are talking of independent variables. If you see explanatory variables, know that they're talking of independent variables. So they have They mean the same thing. This beta 0 here, this beta 0, oh my god, what have I done? This beta 0 is called the constant, or you can also call it the intercept term. This u is the error term. Some people can say at times they will use e instead of u, they will use e. Like here, instead of u, you can put e, they will mostly use u. And by the way, what is this error term? Like I told you, this model is telling you that CPI and GFCF affect GDP, right? Because the independent variables should affect the dependent variable. That is what we are trying to see. But like I said, there are many other variables or factors which can affect this GDP. But we cannot list all of them in this model, else our model will be very long and we'll have thousands of variables. So we include this error term. This error term accounts for the other factors which might affect the dependent variable, but which we don't want to include in the model. So you should know what the error term means. This error term, they also call it like residuals. Another name for error term is residuals. Residuals, or you can call it disturbance term. So that was just an aside. I was just like trying to tell you other names and stuff like that. So I think that is it. The recording has been for almost 2 hours. That's too long. Please watch this video. If you have a problem, ask me. If you don't want to ask me, ask Nigahuja. If you want to ask me, you can send me a message on Teams, or you can come to the office. Oh my God, I hope this thing is recording. Yes, I think it is recording. I'll just check. Okay, bye-bye. Let me stop recording first. Let me stop. What's happening to my e-views? Okay, let me just stop recording.